Well, thank you for being here this afternoon. My name is Joy DeBolt. I work here at SAS, and I have the pleasure of introducing your presenter for this session. This is Imran Sheikh Mohammed from Intel. We are excited to have you here today for your presentation.
All right. Good evening, everyone. So today what we're going to be looking at is how we can accelerate your AI workloads with Intel, be it on cloud or be it on-prem. And we at Intel have a big vision of bringing AI everywhere, right? Be it your laptops, be it your edge devices, or be it your data centers. We are looking at bringing the AI effectively at a cost-effective and efficient way to the entire ecosystem. So you may need solutions for unstructured databases like high performance training, fast connectivity, power efficient inference or cloud or in PC. Intel gives you AI performance everywhere where you need it as such. And that is brought about through an array of software services, hardware availability, as well as a networking standpoint. So we have EC drop-in replacements for most popular AI software that the developers tend to use, be it things like Intel Accelerated Python or Intel Accelerated PyTorch or Intel extensions for TensorFlow. We have all the softwares that's available out there to make your data scientists or the developers' lives much more easier, right? And depending upon which use case that you want to run with, be it a small speech to text model or a small transcription model that you want to run in your local laptop, or even if you want to run a larger model, depending upon the use case, things like summarization or code transcription or even code generation for that matter, you could run that efficiently with Intel hardware and software availability. Now, coming on, presenting to you with the latest CPU that's out there, from latest generation of CPUs that out there with Intel is Intel Xeon 6. So Intel Xeon 6 comes with the P cores specifically has up to 128 P cores with the 6900 series. There is also a smaller version of the CPU which is shown on the left side of the image, which is 6700 series or 6500 series. So these P-core processors are equipped with AVX512 and AMX, which helps you accelerate the matrix operations that are typically involved in the machine learning or the deep learning models that people tend to use. So with Xeon 6, we are also introducing support for something called MRDIMMs, which is nothing but almost 1.4 to 1.6 times faster than the regular DDR5 RAM. What it means is that the data transfer happening between the RAM and the CPU is going to be much higher than your traditional RAM, and this is sensitive for memory bandwidth specific applications. So things like HPC or even things like large language models where the next token latency is directly dependent on the memory bandwidth. We also have comprehensive AI suite which helps with the optimization for all the different workloads from an AI standpoint that your developers tend to look at. Not just from a deployment standpoint, but in the Intel Xeon processors are the best processors for the host CPU for the AI systems that you would like to use in your data centers as well. We've worked with NVIDIA to ensure that the latest SKUs from Xeon 6 have been validated to give you the best performance for your AI workload. Be it distributed inferencing or distributed training, it works great. So double clicking on what is AMX. AMX is a specific built accelerators available in each and every core of the 128 cores that I mentioned earlier of the 6900 series, which is designed from ground up for performing and optimizing matrix multiplication. And when it comes to deep learning and machine learning, matrix multiplication is essential, although there are other operations which do end up using the powerful AVX512 engine that's available in the Xeon 6 processors. Now, how does this translate into business value for you as an end customer? What it means is that you don't need to spend too much or have a heavy upfront investing cost or a total cost of ownership to run your basic AI models for your enterprises. So we cover that from all perspectives. And also, like we mentioned earlier, we cover all the popular deep learning softwares, so frameworks, be it PyTorch, TensorFlow, or inference-specific softwares like ONNX, OpenVINO, or even machine learning specific libraries like scikit-learn or XGBoost. That's available at an optimized format for your developers out of the box without any additional installation of software as such. So not just that, we also have Intel Gaudi AI accelerators that's available for customers who are looking for even major invested deep learning activity. So you do have a dedicated accelerator available from Intel, which is Intel Gaudi. Right now we are with generation 3, and Gaudi processors are available in IBM Cloud, the latest generation that's available in IBM Cloud, and the older generations are right now available for in the AWS Cloud. So it typically comes with multiple form factors. We do have price performance comparisons of those numbers. So if you want to look more about that, if you would like to know more about that, we do have a session on Thursday. It's about at 3:30 p.m. From one of my colleagues, so feel free to join the session. We'll be more than happy to elaborate you on what we have as an offering from an DL accelerator standpoint. Next, coming for the main proof of the pudding. So we'll be looking at one demo where we'll be taking the large frontier model, the DeepSeek R1 671 billion model, which has been quantized with int8 precision type. Nowadays, all the LLMs that gets released, they do tend to have a bfloat 16 precision type or an FP68 precision type. But what we've observed is that our end customers have taken this bigger model, they've quantized it to a smaller format, and made sure that the results that you acquire in terms of accuracy is not compromised from the base model. So what we have done in this demo is we are running the 671 billion parameter model side by side. On the left, you see the model running on the latest Xeon 6 CPUs. That's a 512 core CPU, and it's running the int8 quantized version of the 671 billion model, and you could see that the outputs is relatively frequent as what you would expect from. So if you look into the terms of time taken for next token, in terms of latency, that would be less than 100 milliseconds. That's what we are looking at on the left. On the right, though, what we are seeing is the same model running on the Intel Gaudi 2, the earlier generation processor, earlier generation accelerator. And what we intend to show from here is that if you do not have very strict timelines in terms of latency, then you can run even a larger frontier model just on Xeon 6 rather than investing heavily on other accelerators if it fits the bill. But if you do need lightning fast inference speed in terms of next token latency or serving a large number of user count, that is when you would want to go for a specialized AI accelerator, and that's what we have from Intel Gaudi standpoint. So it's not just with DeepSeek R1. We also have worked coherently with the providers like Qwen, the team from Alibaba who provided the Qwen 3 series of model. The model sizes ranging from all the way from 0.6 billion to up to 221 billion, right? So all these mixture of experts model tend to be much more cost efficient to run on CPUs rather than AI accelerators, for the simple reason being that the number of active parameters is going to be far more lesser than the original active count. For instance here, even though the actual model size is 671 billion, only 37 billion parameters are active at any given point in time. So we have worked with the developers of SGLang to ensure that the expert router models of this bigger model are closely affined to the cache available from a memory standpoint, and it ensures that you get a decent performance on Intel hardware. Yeah. So next what we see is the performance of smaller and medium language models with Intel Xeon. So this is something we've published recently in one of our OEM partners site. And what we are seeing here is that on the box on the bottom, what you could see here for lesser input token size. So if you have like 2K input tokens, 2K output tokens, you could comfortably run 256 concurrent users. We are talking about concurrent users through VLLM, right? So if you are having like a few hundred users who would like to use a generative AI model for a customized generative AI model for their workloads, be it a code generated model or be it a summarization model or whatever be the use case, you could easily do it off with Intel Xeon 6. The same thing on the top. What you see on the top is that with Xeon 6, you could have up to 96 concurrent users when you have 16K as input tokens. And the output token size that is like 4K. So what it technically translates is that even though you have higher input sizes, you could still kind of manage up to 100, kind of approximately 100 users. And this is specific with the SLA of 2-second time taken for first second latency and less than 100 milliseconds next token latency. So the user is literally going to be not be frustrated with the speed of output that is going to be seeing generated in a screen. So that's the value prop we are getting for you as a customer by using Xeon for your LLM use cases. So like we said earlier, it's not just AMX optimizations specific for smaller models, but we also have worked with Meta in ensuring that their Llama 4 herd of models, specifically the Behemoth, the Maverick and the Scout series of model, which are about 400 billion parameters and 109 billion parameters models, are optimized to run effectively on Intel hardware, specifying the CPUs as well as the GPUs. So if I can point you to the token outputs of the Scout model, which is about 108 billion parameters, you could see that it's running at a speed of 454 tokens per second. And the same model with Gaudi 3, you kind of get about 2,857 tokens per second, right? So technically, in a rough estimate, if you look at, you get 10 times as higher output with the latest Gaudi 3 processors. But if you have a lesser user count, if you have a lesser active user count, when you say active user count, it's like number of users constantly connecting at any given 15-minute time interval, right? So if you have very less concurrent users, then Xeon should be more than enough to serve your requests from an enterprise AI standpoint. Now, how do your developers use all these different optimizations that's available there, right? If your developers are very savvy, assuming that you do have unicorn developers, if they are well versed with C++, they can go in and directly talk to the hardware at the from a C++ level standpoint. We do have APIs available for it where they can directly code instructions attributing to AMX and manipulating memory from an MRDIMM standpoint. However, if you have developers who are more savvy in modeling and model deployment standpoint, you can ask them to reuse or replace their existing software stack with Intel provided software stack, right? Be it modern or be it Intel optimizations available for Pandas, or like we talked about PyTorch, TensorFlow, Intel drop-in extensions, scikit-learn extensions, XGBoost optimizations. All these are available for free for the developers to use out of the box. There is no extra licensing that needs to be paid. There is no additional optimization that needs to be done for your developers to be using these benefits with Intel hardware. So Right now, from an availability standpoint, Xeon 6 is available with major OEMs. You could talk to your OEMs and try and see how we can get it. If you are looking at availability from a cloud standpoint, it's the latest generation of Xeons is being rolled out with all the prominent cloud providers. However, the last generation of Xeons, which is generation 5, is available on AWS, Google Cloud, Azure, and Denver DataWorks. And even we do have Intel Tiber Cloud, which is our internal value proposition, which gives you access to Intel hardware at very cheaper rates. So feel free to reach out to us if you have any questions in terms of how you can acquire the latest Intel hardware software products, or have any specific queries on how you can optimize your workloads to run best on Intel hardware. That's all I have for today. Any questions? Yeah. Definitely. He has a question.
Can you use
Yes.
this model to build your own AI system?
So when you say AI system, can you please brief a bit more on that?
I mean, as in something similar to ChatGPT.
Oh, definitely yes. So the demo that you saw here, this is an open source web GUI, right? This is an open source web GUI. You do have options to click on deep search. You do have options to type your question out. You do have options to click and drag and put your text input into it and pass it through the model. So open source components are available to be hosting this kind of a setup in an Intel CPU or a Gaudi processor standpoint. Yes. So if you want to have your own in-house ChatGPT, yes, you can do that. Sure.
I'm with Imran. I'm from Intel as well, and there is follow-up presentations. There is a spotlight presentation happening on 8th between 3:30 and 3:50. So basically, you can come down there, and please come down to our booth as well. This technology can be explained at detail, and I think the bottom line is practical solutions. With Intel Xeon having AMX as an accelerator, has improved perimeter of workloads that can be achieved within the Xeon itself. And with a given proper SLAs and sizes of the models, we encourage you guys to run POCs. And of course, there is a need for acceleration for a large-scale models, a large-scale training. And we do have a GPU versus an ASIC. Gaudi ASIC kind of a choices that you can make as you're deploying at scale. Okay, thank you.
Thanks, everyone. Sure.
So my quick question is, usually, companies will have some concern on the data privacy if we leverage on, generative AI tools. So,
Yes.
so for the one that you shared,
Yeah.
can you talk something about the controls or security, that's set up?
This is running in a data center. It's not on the cloud. It's running inside a data center. It's hosted on-prem in Intel's data center. So we are just trying to showcase this to you, saying that you can copy the same setup in your data center. So
In my data
in your data center, yeah. So we can provide you with the software and tools that you need to it. We can point to how to configure all these different things, and you can run the same thing straight out of the box that you have in data center.
I see.
Yeah.
So that means there's a less likely kind of a risky to
Exactly. So
to
your
leak
data.
the data to.
Yes, your data doesn't go out, it stays inside a data center. And if you want to add another level of security to it, we do have security guard extensions and TDX specifically to ensure that the data that is inside the data center as well as within transit is secured with all the different components that's needed be.
Got it.
Yeah.
Thank you so much.
Oh, definitely.
Are there any other questions? Wonderful. Well, thank you so much, Imran.
Thank you.
And thank you all. If you could please put your headsets back at the table that you received them. And thank you all for joining.